Swiss charts. In this video, the following topics will be discussed: GAFOR, QNH charts, wind barbs charts, upper lever charts, upper wind temperature charts, Alps, low-level significant weather chart. GAFOR. The GAFOR, General Aviation Forecast, is an essential chart for navigation in Switzerland. It shows, at different time intervals, the meteorological conditions along mountain passes. For our operations, it is fundamental because the GAFOR also covers the passes required to reach the alternate aerodrome, namely Lugano. It is extremely important to check the validity period of the chart. The most relevant mountain passes are assigned a number. The number identifies the route. A white box containing the number indicates the highest terrain elevation along the pass. 3 boxes, each with a validity of 2 hours, contain the meteorological conditions of the pass. These conditions can be open, difficult, marginal, closed. These conditions depend on visibility and cloud ceiling. Below the boxes, additional symbols may be present indicating the meteorological phenomena affecting the pass. Open. When a pass is classified as open, this means that visibility is at least 8 kilometers and the cloud base is at least 2,000 feet. Attention! Open does not mean perfect. 8 kilometers of visibility is not ideal for visual flight rules flying. However, experience shows that when multiple passes in the same area are open, conditions are often favorable for visual flight rules. Attention! The cloud ceiling is measured from the ground, in this case from the reference altitude of the pass. Therefore, to determine the cloud base, it is necessary to add the ceiling value to the elevation shown in the white box of the pass. Difficult. A pass classified as difficult corresponds to a visibility of 5 kilometers and a ceiling of 1,500 feet. Under these conditions, it is recommended to limit flights to those with a flight instructor on board. Marginal. A pass is classified as marginal when visibility is 2 kilometers and the ceiling is 1,000 feet. In this case, it is often a no-go. Closed. A pass is classified as closed when both ceiling and visibility are 0. In this case as well, it is obviously a no-go. To better understand how this chart works, let us look at a practical example. Let us assume we want to fly from Geneva to Grenchen, following routes 41 and 11. This chart is valid from 12 to 18 UTC. Both passes for the first 2 hours, therefore from 12 to 14, are classified as difficult with haze. From 14 to 16 they are open, and then they return to difficult conditions from 16 to 18 UTC. For this flight, the ideal time to navigate along the route would therefore be between 14 and 16 UTC. Please note that wind is not a relevant factor on this chart and it is not taken into account. Strong winds often help to clear clouds from the mountain passes, causing all passes to appear as open, even though in reality they may not be practicable due to the mechanical turbulence generated by the wind. Tips: a cross-check of the conditions published in the GAFOR with the webcams available on windy.com can provide better situational awareness during the flight briefing. QNH Charts. This chart, specific to Switzerland, is essential to understand certain meteorological conditions in Ticino. The orography of Switzerland is unique because it is crossed by the Alps. The Alps form a natural barrier to meteorological phenomena, and it is possible to have extremely different weather conditions between the north and the south of the Alps. Even though it only takes about 30 minutes of flight time to cross them, weather conditions can vary dramatically. This chart allows us to observe 2 fundamental parameters: The pressure difference between the north and the south of the Alps, namely between Zurich and Lugano, and the wind at flight level 100. Since several charts are published each day, it is essential to verify that the correct chart is being used by checking its validity period. As you will study in meteorology, a pressure difference between two areas generates a movement of air masses and therefore wind. In most cases, the wind moves from areas of high pressure toward areas of low pressure. There are three possible cases: negative pressure difference, meaning high pressure in the north and low pressure in the south; zero or negligible pressure difference, when the two pressures are similar; positive pressure difference, meaning high pressure in the south and low pressure in the north. Let us start with the first case, as it is the most critical for our flight operations. High pressure in the north and low pressure in the south, negative pressure difference. Air masses always move from high pressure toward low pressure. Consequently, this pressure configuration very often generates a northerly wind. In Ticino, a northerly wind is called föhn. According to the chart, föhn starts to become relevant when the pressure difference exceeds -5 hectopascals. The moist air coming from the north encounters the mountains and is forced to rise. This forced lifting cools the air mass and creates clouds and precipitation on the northern side of the Alps. Once the wind reaches the mountain peaks, it descends into the Ticino area while warming up. Typically, the air is dry because the precipitation has occurred on the northern side and the air mass has lost most of its moisture. As the air descends, it warms, causing the clouds to dissipate and leading to generally sunny conditions. However, as the wind descends and is funneled into the valleys, its speed increases, and due to the terrain orography, the airflow becomes irregular, generating moderate to strong turbulence. Often, the wind does not reach the ground surface but remains at about 500 to 1,000 feet above ground level. This means that on the ground the wind may be calm, but immediately after takeoff, strong turbulence is encountered. This is a condition in which flying is not recommended, especially for solo flights. Experience shows that when the pressure difference is greater than -6 hectopascals and the wind aloft is stronger than 20 knots, it is better to remain on the ground. Understanding this phenomenon is fundamental because flights are often cancelled under apparently perfect weather conditions, such as sunshine, warm temperatures, and calm wind at the surface, while in reality a föhn condition is present. This can only be identified through the study of this chart. Zero or negligible pressure difference, when the two pressures are similar. This condition does not usually lead to significant meteorological phenomena. However, it is always important to observe the wind at flight level 100. When it exceeds 20 knots, regardless of direction, valley flying is usually very turbulent and poorly suited for solo navigation missions. Positive pressure difference, meaning high pressure in the south and low pressure in the north. This condition is the opposite of the previously described effect. In this case, southerly wind can be expected. This is known as south föhn or Stau. Cloud formation occurs south of the Alps, often with heavy precipitation. North of the Alps, the wind will be dry and turbulent. Regardless of the intensity of the pressure difference, meteorological conditions are stable. For this reason, layered clouds are often present, and turbulence is generally absent. Consequently, flying with a positive pressure difference usually does not cause problems other than the presence of clouds and rain. However, it is obviously not recommended to fly north, where conditions similar to the föhn described in the first example would be encountered. To summarize, When the pressure difference is negative and the wind aloft is stronger than 20 knots, it is very likely better to cancel the flight to avoid encountering moderate turbulence. When the pressure difference is stable, no particular conditions are expected, but it is always good practice to check the wind aloft to understand whether valley flying will be turbulent or not. When the pressure difference is positive, turbulence is not expected, but stratified clouds and precipitation are likely. Flying should generally not be a problem. On many websites, it is possible to find pressure trend information. In the video description, you will find the source that, according to our experience, is the most accurate. This makes it easy to anticipate phone and stow conditions up to 1 week in advance. Wind barbs charts. This chart is a wind barbs forecast chart for Switzerland and the surrounding areas. It represents the forecast wind direction and wind strength at different altitudes above mean sea level, up to flight level 200. The chart is valid for a specific time, which is always indicated in the top left corner, and it is essential to verify that the validity time matches the planned flight period. Each black vertical line represents a wind observation point. The orientation of the barb shows the direction the wind is coming from. For example, if the barb is pointing downward, the wind is coming from the north. If it is pointing upward, the wind is coming from the south. The blue lines and small flags attached to the barbs indicate wind speed. Each long barb represents 10 knots of wind. Each short barb represents 5 knots. A triangular flag represents 50 knots. The total wind speed is obtained by adding all the barbs and flags present on a single wind symbol. The different levels along each vertical line correspond to different altitudes. These altitudes are listed in the legend at the bottom left of the chart and are expressed in feet above mean sea level. Typical levels shown include 2,000 feet, 5,000 feet, 7,000 feet, 10,000 feet, 15,000 feet, and 20,000 feet. This chart is extremely useful to identify strong winds aloft, wind shear, and potential areas of turbulence, especially in mountainous regions. Strong winds at higher altitudes, even when surface wind is calm, can lead to mechanical turbulence, rotor formation, and very challenging flying conditions in valleys and near terrain. Upper wind temperature charts, Alps. This chart, in addition to showing wind direction and wind strength, also shows the position of the freezing level, expressed in feet. This chart is important to understand at which altitude 0 degrees Celsius is reached, and consequently, to make considerations about possible icing conditions. At times, more than 1 0-degree isotherm may be present. When this occurs, it indicates the presence of a temperature inversion layer. Upper lever charts. In the Sky Briefing package, additional charts are also displayed. However, these are intended for higher levels, from flight level 100 and above. Therefore, for our visual flight rules flights, they are not very useful. These charts can be skipped. Low-level significant weather chart. This is a very important chart for VFR flying. It shows weather phenomena below flight level 100. All the symbols shown on this chart can be found in the Meteo booklet on the student website. The chart is divided into 2 areas, east and west, and you can find the outlooks for each area at the bottom of the chart. Experience teaches us that these charts are often accurate, so the symbols shown should not be underestimated and must be fully understood. As mentioned before, on the student website you can find the Meteo booklet with the symbols shown on the chart. For a quick weather briefing, it is necessary to study them. The study of the charts is complete. In the next video, meteorological observation and forecast bulletins, NOTAM, and military activity bulletins will be analysed.